Hello and welcome everyone to today's webinar, Kubernetes Without Borders, Building Multi-Tenant Apps that Span Clusters and Cloud Providers with KubeSlice. My name is Tara Van Cleve and I'm a Marketing Event Manager for the Developer Initiative here at Oracle. Today, we're excited to show you how you can seamlessly expand your Kubernetes workloads across multiple OKE clusters, regions, and other cloud providers. If you do not currently have an Oracle Cloud account, we do have a special promo with extra credits so that you can try out the OCI services after the webinar. And to access that promo, please sign up using the same email you registered with for the event. We'll also be recording the session today, and the link to the recording will be sent to you via email in the next couple of days. If you have any questions during the webinar, we've set up a channel in our developer public Slack called Webinar OKE KubeSlice that you can access at the QR code or at bit.ly/odevrel_Slack. Once you're in, you'll land in the general channel, and from there you can search for the webinar channel. We'll also be checking the Zoom chat and the Zoom Q&A areas throughout the webinar, and we'll open up for live Q&A after the demo. Today's webinar will be presented by Jeevan Joseph, Principal Product Manager at Oracle, Prasad Dorvala, Chief Product Officer at Avesha, and Olivia Rakshit, VP at Avesha. So without further ado, I will hand it over to Jeevan.
All right, so welcome everybody to this talk on Kubernetes without borders, right? And thanks, Tara, for the introductions. I'm Jeevan, and I'm joined by Prasad and Olivia from Avesha. So let me kind of set the stage here a little bit with Container Engine for Kubernetes, right? But before we get there, let's kind of quickly remind ourselves why most of us are using Kubernetes, right? Now, this talk is really geared towards people who are using Kubernetes today, but even if you're not using Kubernetes today or you're getting started with Kubernetes, you're going to walk away with something really valuable here today. Now, I can remember like back in 2016, 2017, I was working for an ad tech company, and that's when we really started using Kubernetes. And, our main driver to use Kubernetes was, our release management, right? Developer productivity. We always kind of felt like we were like always gridlocked with our releases, mostly because there were like multiple service teams trying to deploy. We were deploying on VMs at that point. And, we wanted to move to containers. And like, once we started moving our applications to containers, there were so many containers and, orchestration became a key driver for us. So eventually we, kind of gravitated towards Kubernetes around 2016 and 2017. And, for each of you who are using Kubernetes today, there could be multiple reasons why you're using it, right? Some of you could be using it for the auto scaling and resource utilization features that Kubernetes offers. You want to have multiple application development teams share infrastructure, but still in an isolated way. You want to have developers being able to work on their own release trains and, deploy to production in common infrastructure. You could be having a multi-cloud strategy, and Kubernetes makes this whole notion of portable applications a reality because it has a standard packaging format, it has a standard deployment format. It's really easy to pick up applications and deploy across clouds without having to deal too much with cloud-specific or vendor-specific APIs and vendor-specific tooling and such. So regardless of what your key driver or the key, magnetism towards Kubernetes is, these are really some of the promises, right? Like that attracted all of us to Kubernetes, right? Now, once we've reached Kubernetes, let's take a quick peek at like, have we really been able to achieve all of this? And like to what degree, right? And I'll leave this here because we're going to revisit this really quick. And let me also set the stage with Container Engine for Kubernetes from OCI, right? Container Engine for Kubernetes, or OKE, is our managed Kubernetes product. Now, if you have used any managed Kubernetes product in the past, like it could be AKS, EKS, GKE, or any one of the managed Kubernetes offerings, you have a fairly good understanding of what OKE is like, right? Like all managed Kubernetes products, we have a fully managed control plane. We also do highly managed data plane components. We support all the standard Kubernetes auto-scaling features and other capabilities. Now, all of this is delivered on top of OCI's innovative compute, right? So, the things that set us apart are things like flexible compute, right? Like our Kubernetes worker nodes, you might be thinking that, standard shapes like 8-core, 32 gig shapes, or like, 16-core, 64 gig shapes, they might be like maybe too many or too little. So, our Flex Compute lets you create your own shapes, right? Like it's, if you want like a 13 core, but it's a highly compute bound application, you just want 8 gigs of memory with it, right? That's possible, right? The same goes for load balancers, right? We have flexible load balancers that will, dynamically scale based on actual usage. OKE is standard Kubernetes. We are fully conformant with the Kubernetes certification process, and we offer this on top of our, Gen 2 cloud infrastructure, right? We also provide some additional features like Node Doctor for troubleshooting. Now, features like this can really drive down troubleshooting times and support interactions, right? Because, we've all been there where, support asks for, hey, can you upload this log file? And you upload that log file. And hey, can you upload this other log file? And you go and upload that log file. And this back and forth continues for hours or maybe a couple of days. Features like Node Doctor can really help cut down on all those back and forth time by creating a support bundle. It creates a report including all the log files that are from those nodes, and it really helps drive down to root cause analysis and things like that much faster. OCI obviously is used in a lot of highly sensitive environments, so that makes our offerings compliant with a lot of security standards like STIG and others. And again, the whole notion behind OKE is we want to provide a highly available by default. In fact, we don't even have an offering that is not highly available, right? So sensible defaults, a very secure security posture by default, and still staying true to the open standards in Kubernetes, right? Now, like I mentioned, like a bunch of things would have attracted us to Kubernetes in the first place, right? It could be developer productivity, it could be the scaling features, and it could be many, many of those things, right? And Kubernetes solves a lot of these problems for us. However, what are the challenges today? The way I kind of think about this is, as we solved those little problems, we have kind of widened and expanded on our horizons. So we're now starting to tackle slightly larger problems, right? It's kind of like you're going subsonic and, your immediate next step is going supersonic. But once you reach supersonic, you don't want to stay there. You want to go hypersonic, right? So this is kind of what we see across the board, right? With a lot of people deploying to Kubernetes and their smaller problems already addressed by Kubernetes, with its default and default capabilities. We're now starting to look at slightly larger problems, right? Like, how do I have my distributed application not just be inside a single cluster, but how do I geographically spread that across the globe, across multiple geos, right? I still want this to act as a single application, but I want to work with multiple clusters. Now, with Kubernetes today, Kubernetes' universe is the cluster, right? And generally, at least with most cloud providers, these clusters exist in specific regions, right? So, but what if we want to go beyond that, right? Have workloads that span geos, right? And the same goes for multiple cloud providers, right? A lot of our customers are using multiple cloud providers, right? Anybody who's using Kubernetes today, at least managed Kubernetes today, they would be thinking about, hey, I have some investment in an existing cloud provider, but maybe I want to move to or start using another cloud provider, maybe because of geography, or maybe because region availability, maybe because of security, or maybe it is because certain workloads have a natural affinity to certain clouds, right? Like for instance, Oracle Cloud does a lot of Oracle database related workloads, right? So there are natural affinities to certain things, and you always want to pick the best tool for the job or the best cloud for your application. So how do you create this web of microservices where some of these services are better run in some clouds and some of these other services are better run in other clouds, and how do they seamlessly communicate, right? And you might also be looking at multi-tenant workloads now, right? Like instead of dedicated infrastructure for doing multi-tenancy, you might want to use a single cluster because that makes your whole development lifecycle process a whole lot easier, and it makes it much more standardized. And how do you run true multi-tenanted applications within Kubernetes clusters, right? So these might be the new class of challenges that we are seeing. And Kubernetes, being this open ecosystem, it promotes and helps create these extensions and solutions to address a lot of this. And to talk about how Avesha and KubeSlice is addressing many of these challenges, let me hand it over to Olivia from Avesha. Olivia, take it away.
Thank you, Jeevan. Loved your hypersonic analogy. That was great. Yeah, great introduction. So following up to what Jeevan said, hello, everyone. I'm Olivia. And as Jeevan was describing that the challenges that we are facing now is how to have applications communicate with each other across network domains in a multi-cloud scenario, how to have multi-tenancy be implemented very easily, very seamlessly across distributed infrastructures. So those are some of the things that we are addressing with KubeSlice, and we'll take you through a demonstration that Prasad will do. And we'll talk about those things a little bit in the beginning. So multi-cloud with KubeSlice. So some of the things that our technology brings is the flexibility. So we have a one management control plane for all clouds. So when you want to be able to view, whether it's latency charts, whether it's how your services are communicating with each other, or which namespaces are talking to which namespaces across clouds, through this one control plane in KubeSlice, through one UI, you can view the whole thing. So what we essentially do, what you're seeing here, is we create these slices, if you will, across clusters. And these clusters can be across clouds, they can be across geographies. They are what we call virtual workspaces, or virtual clusters, if you will. And they are a group of namespaces that we bring together. So as Jeevan mentioned, you can have your Oracle workload namespaces, and you can have your front-end properties in another cluster, but all of them as part of one slice, and they can seamlessly communicate with each other. And what the slice creates is a unified network. And you can have several of these slices across the distributed infrastructure. So if you can go back to the earlier slide. Now that you've gotten this picture a little bit, so we'll go through the benefits that KubeSlice brings with multi-cloud. So we bring that flexibility. We also bring the security. So as you see that we kind of slice the infrastructure, so we are reducing the blast area, if you will. So you create that virtual cluster with a smaller subset of namespaces communicating with each other. And each slice really has a hard, isolated, secure boundary with other slices. Namespaces from one slice cannot communicate with services or namespaces within another slice. And so that way there is no infiltration, if you will, in case of any vulnerabilities. So it's highly contained and secure, that whole the slice workspace. And then for performance, the slice is essentially an overlay network. So, and it helps in low latency traffic, low latency communication, low latency connectivity across clusters and across clouds. You can set bandwidth priorities. You can say, okay, this slice, if you have multiple slices, you can say this slice is for high priority traffic, and this slice is for medium priority traffic, and this one is for low priority traffic. And we take care of the isolation of the traffic at the network level as well. And then the availability. I think Jeevan alluded to high availability as well. What you can do with the slice, extending the slice to multiple clusters, again, across regions and clouds, is very simple. So you set all the properties of a cluster in one slice, and you can extend it to other clusters across regions and clouds, so that there is no config drift and there are no errors, and the same configuration is deployed across your entire deployment, again, geographically. So essentially, we are giving you a very easy way of creating a one network for your distributed applications to seamlessly, talk to each other and discover each other and communicate with each other and be deployed in this one network across clouds and across distributed architectures. So this is a visual representation of how you would do a multi-tenant architecture with KubeSlice in a multi-cloud scenario. So here if you have multiple teams, we have customers that create slices for different teams. So a staging slice and a production slice. Again, they are all isolated. They are isolated. Their network traffic is also isolated, so it's all highly secure. And the slices are communicating, and you can set specific properties, like you can set RBAC rules for each slice. You can have resource quotas at each slice level. And then you'll get, through our user interface, you get visibility and monitoring for each slice. And you will see all of this in the demo that's coming up. And you can even, with the traffic isolation, you can set specific network policy at each slice level, and bandwidth guarantees, as I described earlier. So again, a slice so one of the benefits is also the cost. Like for each team, you don't have to set up a new cluster. You can have fewer number of clusters and create these slices across distributed clusters instead, and have a different network for each set of your applications. And then this one was similarly, if you're a SaaS environment and you had different customers, each customer can be placed in a separate slice, in a separate isolated environment. Like here we have the example of Neural Tech and Robofy, two different companies, two different slices, and you can set each different sets of properties, infrastructure properties and application level properties that consume the infrastructure at the slice level, and have that isolation and a virtual network and a virtual workspace for your applications. So that's the premise of what a slice brings in a multi-cloud, and in an easy way of providing a multi-tenant infrastructure for your applications. And over to you, Prasad.
Thank you very much, both of you. I think Jeevan said it right? One thing is, why do we use multi-cluster? I think Jeevan alluded to some of the use cases when you go from one cluster to another, two clusters, right? You might say, I want to have US East and US West, or I might have a geographic boundary where I would kind of say, hey, do I have resiliency associated with that, right? That is one use cases which you go multi-cloud or multi-cluster. And it can also be cloud, right? Somebody might decide to say, hey, I may be in one cloud, but I want to also have another cloud for region availability or whatever it is, right? So there are different business use cases where people go. And there are people who are going from 2 to 10 or a different number of clusters. I think right now the studies show that typically enterprises have close to 70 to 80% enterprises have beyond 10 clusters, right? That's the data which we are seeing. Then there are customers whom we are talking, we have hundreds of clusters, right? So the cluster as a unit of measure, which G1 talked about, that's the cluster boundary, which is kind of causing some challenges with respect to how do you distribute the applications, but also gives some flexibility from a container, and clusters are growing bigger and bigger. One thing we all know, definition of a cluster, right? By definition, the network is a flat network inside a cluster. Every pod needs to talk to every other pod, right? That's the definition of a Kubernetes cluster. Now, you can do network policies and others to isolate it, but you can also do RBACs, which namespace you want to have it. This is all cumbersome, right? There are people like OPA, Kyverno, and other policy management guys who can give you that. I'm not saying that you should not use those things, but this Kubernetes, as Jeevan alluded to, it's an open system. This has a lot of cloud native projects. By the way, KubeSlice is also a project in the open source, right? We have an open core, so we also open source some of our foundational elements, but the problem still is very apparent, right? In my previous incarnation of different jobs, right, where EU doesn't want data to move to North America. Why? Even California, guys in California have a regulation as to where the data needs to reside. So there are lots of data sovereignty issues which people tend to have a different way of doing things, right? But there are common apps on the back end. There are common apps which actually do synthesis of different things, right? Let's take that is reason why people go with multi-cluster or multi-cloud, right? And then when you go larger, now edge is becoming much more popular, right? And people are going to get benefit of the closer to the customer. Everybody you think of are a SaaS provider, right? SaaS is the right way of getting the MRR, monthly recurring revenue, from a product to so-called monthly recurring predictability of your revenue and all that stuff. So people are doing SaaS. Now, when you have a SaaS solution, your reach is pretty much all over, right? Once and your customers are wherever they are, you want to reach them. So people are trying to go and say, how do I get my application closer to the customer who is consuming it? So that gives you the whole notion of edge. Now, when you see this transformation happening, your application guys, I mean, first of all, the persona who is doing all of this thing is the platform engineering team, which is offering that services over to the business guys who are building applications. One of the key problems which I always used to have is that application guy do not want to know about the network. If you were to say, hey, if I have to connect these and these two applications need to talk, the NetOps would always have to figure out how do I connect them. Then security comes into play. Hey, do I have the right kind of scaffolding from a security audit point of view? So because before you do any good, don't do any harm, right? You want to make sure that there is no security vulnerabilities or open ports and stuff like that need to happen. So those are all the challenges. So is your application ready? Is one challenge which we always used to ask myself is when you're offering this infrastructure, we would go talk to the business guys and say, can I distribute them? So those challenges are always a kind of a sticky point, like friction between platform and business app guys. One way of doing it is clone them, right? Which is essentially to have full stack all over the place, right? I can tell you, in my experience, we had an application which was using Oracle and Rack. Rack is the best thing which is available for a highly transactional application, which does phenomenal job on all that. Show me anybody, any cloud provider which offers Rack. Nobody, right? AWS doesn't offer, nor GCP or any other places. So business applications which we have used, we are so used to Rack that it was very difficult for us to go to why we have spent a lot of time trying to figure out how do we transform that to different applications. It was impossible. The performance is so good in that. So now you have a footprint in Rack, which you want to have, but you have already modernized your applications to microservices. So and you may want to have closer to customer, which is on the edge. How do you distribute that, right? So here you are, through KubeSlice, we are trying to say that makes it much more easier with the KubeSlice solution, right? So one example we're going to show is that how do I distribute microservices, but I use ATP, the transaction processing services outside of Kubernetes cluster, but you may have mid-tier applications running in OKE or Oracle Kubernetes engine, and then as well as some web properties or something else running in different clouds. That's one case, right? Mergers and acquisitions in a lot of enterprises that do happen because people have different sets of properties which they have built in. So now how do I consolidate them, or how do I consolidate them, rationalize them, or do I bring them together? There are projects which run years trying to consolidate it, right? So that is where the challenges come in, and we as KubeSlice, we are trying to say, stop. Don't spend too much time refactoring. You have your existing, microservices. How do you sweetly fit into those clusters? And then make sure you create a framework to look like one virtual cluster across multiple clusters. That is what KubeSlice is, right? So let me go under the hood, right? Multi-cloud networking. So we all know multi-cloud networking in one way, right? Kubernetes does phenomenal job through CNI inside the cluster. And if you want multiple clusters, be it in the same cloud or be it in a different cloud, right? Either you have to use cloud services or you have to put a flat network of trying to figure out your subnet mask here, subnet mask there. That is a painful process. That takes a lot of this thing, but how many clusters do you design, right? So that makes it a big friction between an application guys, because today, velocity is the most important thing for an application guy. As a SaaS provider, you want to be nimble, you want to deploy it faster, as Jeevan alluded to. That's the reason why we went to containers. That's the reason why we said, how do I shut them down? Now, did we create an artificial boundary, or like Jeevan said, we are now going into bigger problems. How do we solve the bigger problems, right? You cannot extend a cluster control plane across multiple regions, because that is not the way Kubernetes is designed, or it will not work effectively. It does work, but it will not work effectively, not a production system to do that, right? So the production system, you want to have the control plane closer to your worker nodes. So that's the reason why we looked at it. And then we said, what is your security first principles? The security first principles are reduce your blast surface. Don't expose everything, right? How do I constrain it? Now, from an application standpoint, what is the perimeter for application inside Kubernetes? That is namespace. You would say, I will give you a namespace. You guys have a couple of microservices or however number of microservices you are boxed into the namespace. Now, microservices, the more we break down these monoliths into many microservices, the microservices are growing many in number, right? So now you cannot sit in a single namespace and then have all the microservices from different versions or different iterations, because your CI/CD pipeline is deploying it at best probably 100 times a day or more, right? So there are lots of people who are deploying it every day, many microservices. So how do you constrain them, right? So what we thought is our multi-cluster networking or multi-cloud networking should look like Kubernetes first principles, which is a flat network across multi-cloud, right? So that you don't have to worry about, do I have to do a flat network per cluster, or when I go to cloud, I don't have control on CNI much. It is 10 dot address space. So do I have to worry about that? I bet you anybody in here, when you go to an enterprise and ask for an IP address allocation, they will give you a look that you don't want to have that look. I've seen enough. And the security guys are going to be looking at you and say, you are trying to punch a hole through firewall to go across. Where is the traffic? Then the API traffic comes into play. What is exposed? How do you throttle that? So there are lots and lots of things, right? So Kubernetes solves it inside a cluster. Now, the question is, how do you make this north-south traffic, make it look like east-west traffic, and also stay in the same security perimeter? You don't have to jump from the cluster to cloud services to internet services or something like that, right? So there are different grades of transformation which you need, or transition which you need to have from a traffic standpoint if you want to go from one cloud to another cloud. Now, how do we make that seamless? And then how do we do? So KubeSlice addresses that, right? It combines the one distinction, if you want to take away, when you talk about KubeSlice versus multi-cluster networking, we do networking, overlay networking with groups of namespaces only, right? You don't have to have entire cluster participate inside that. You can have multiple slices per cluster, and each slice need not have the same topology as the other slice. Slices can have different clusters join into it, not necessarily the same pattern inside the thing. So that gives you the flexibility. Let's say you have analytics application which you want to have in 2 or 3 locations, but with that there is some other application which you want to have it in 6 other locations in different places. How do you construct that? That is what KubeSlice solves, right? It helps you deployment velocity. Now, an application guy doesn't need to know, do I have to expose this through an API? Or do I have to have an annotation saying that this is this cluster? All that is taken away, number one. Number two is that, this gives you the advantage that you can, it's an ephemeral thing. You can remove the cluster or add the cluster on demand, right? And everything is cloud native way and Kubernetes native way. The routing, everything is built into the Kubernetes. You don't have to go external, except for the if you were to have a load balancer services and stuff like that. But one other advantage which we want to be very clear here is across the clusters. If you want to communicate, it is layer 3 and above. It doesn't have to be layer 7. There are lots and lots of streaming services. There are lots of data replication services. There are lots of, there are edge cameras which are coming in, and then which is actually streaming RTP and other solutions, which needs, layer 3 and above network, not a layer 7 network, right? So how do you handle all that is built into KubeSlice. So the overarching solution is we are agnostic about Kubernetes distribution. You want to have Tanzu, you want to have OKE, you can GKE or AKS or EKS, or an edge like Cox Edge. Our partner Cox Edge brings in Kubernetes to the edge closer to the customers. You can connect them through that, right? So that's the advantage. Edge is becoming very relevant in web properties, inferencing properties, like for instance, smart cities have cameras which actually have a whole bunch of images taking in, and then somebody is inferenced at the edge, but the model which is running inside the cloud, right, which is centralized in some place. So those are all factors which we see happening inside the industry at this point. So the overarching architecture, as Olivia talked about in some of the conversations she had, one of the important thing when you have fleets of clusters which you are working, config drift is one fundamental problem, right? Who is accessing what and who is changing what is one fundamental problem. So the control plane is also yet another cluster or something which you want to isolate in, is something which we separated out. By the way, all this data is not, is Kubernetes native. So essentially all of it is stored in etcd, which you can replicate it and then have multiple controllers. And the fleet of clusters, we are not changing much in the fleet of clusters. It's vanilla Kubernetes, but with certain set of operators and CRDs built into it, gives you the data plane and manageability of creating this whole notion of namespace-based overlay networking, right? So let me just give you some more details. I don't know if any of you are networking guys. So you still have CNI, or on top of CNI, you would have an overlay network. And that gives you an isolation, that gives you ability to create a unified flat network across multiple clouds or clusters, right? It also helps you do, export and import services across clusters, so that whichever services policies you can have, what is let's say in a data sovereignty situation, some of the services you don't want to expose, some services you want to expose. So those are all foundations which you can give. Thank you. as Olivia mentioned, right, you can register multiple clusters, in this case, AWS, GCP, and Oracle. Right? You have a dashboard which actually shows you per slice basis. Let's say, in this case, there is a EU cluster and US East cluster, Oracle, both of them are in EU. So each slice can be a set of teams or a set of customers, right? So if you look through that, let's say, Cockroach DB is you want to have different sets of clusters, go around across different things. You can do that. And then it gives you much more insight into how is it performing with respect to inter-cluster communication, what's the latency look like, all that is maintained. Sorry, my bad. Right? You have through single cluster, you can get into dashboards of what is happening inside it. Literally, you can look at all the namespaces you have, which is integrated with the Kubernetes dashboard. There are some failed workloads. How do you handle it? Prometheus in node exporter. So likewise, you can kind of see this is a live system which is actually happening in different places. You can look through that, right? So that all these things are very easily done through user interface, and then you can pass all the controller is the source of truth. So essentially, what happens is that if you are doing anything in the fleet of clusters, those fleet of clusters are always verifying with the controller. And then if the controller configuration is different, they will literally put back to the configuration where it needs to be. So now you can tighten it down as to who has an RBAC rule inside that, right? And another advantage is from a resource management standpoint, you have a single, say, for instance, you have a let's say in this case of an Oracle, you have a worker one cluster and a worker two cluster, US East and different places in AWS in this thing. You can kind of say, how do I add resources? How do I put number of resources and then enforce them in an easy way? So one thing you can do is take all these configuration and then put it into your Git repo also, right? So that you use a visibility, get that Git repo, and then push it into the clusters, right? So there are different ways to manage it, be it RBAC, be it resources, be it onboarding namespaces, right? If you have more namespaces to be onboarded, right? Let's say this boutique slice, you can kind of say, okay, different namespaces are out there. Can I add them and then add them to the slice so that you can bring in more different namespaces into a slice? So I can tell you that we did, MuShop, which is, thanks to G1 and Oracle team. It's a very complicated app, right? Which actually does phenomenal job of, you can use ATP services outside of the cluster, but you can have microservices talk to that, right? Now, there may be a certain set of services which are actually need to be centralized in Oracle, and there may be storefronts which you already have in different places. How do we make that happen? So in fact, this particular thing, if you see that this is 54.230, that's the IP address. I can bring you that this is the AWS cluster, and then you can see that this 54 is an AWS cluster, right? It is look at it. It's in US East or AWS cluster. If I get K nodes -0 wide, it tells you that this is the IP address, external IP address. And by the way, it is running on a node port service. So now I ran this node port service, which is actually talking to a Oracle database inside Oracle Cloud. And some of these services are running in Oracle, and some of these services are running in AWS on a slice. So it is so simple that when you go to this and then say, service discovery, let's say Oracle Slice. So it tells you what services are in MuShop, what services are exported from where, at what time, all that stuff, right? So that now you have a distribution of workloads. You don't have to have full stacks in different places. Literally, if you look at Cox, which does edge services, right? There are many places where you have shopping centers and different things. So you can distribute some of those application in these edges, like the way Cox Edge provides. And they have Kubernetes services, different Kubernetes and different other services, and then connect it to Oracle Cloud. And that's where your data gravity is from your application and some of the services which are used for, which is very good. So as I want to highlight, it is important. It is not the compute. It is the other services which are important, right? From the business standpoint, when we were transforming our application, Oracle, we couldn't get out of Oracle, or we don't want it to get out of Oracle, because Oracle provided the rack services so important for our service. So we had to go use that, but you wanted to be modernized to have some of the workloads. So OKE is one place, and then there are places where we wanted to be, our SaaS solution was global, so we wanted to put that services, some of the services in different places. Those are the kind of use cases we have done. And KubeSlice Manager brings in various ways of showing service-to-service communication. As you can see here, these two are communication between the clusters, right? So it tells you the bandwidth. You can throttle the bandwidth and different things. I think I need to give, it's an example. Applications, we have it for Boutique app and different clusters and different things. It's something which I would leave it for now, because we also have integration to IAD, any authentication solutions. As as G1 provided, you can have projects. Projects is a way of tenancy to create different sets of tenants, and you can have multi-cluster scenarios, so you can see what's happening from a cluster to cluster communication look like, and across different things. So I'll stop it there. Let's take questions. I know we are just about 10 minutes before we wrap up. Thanks for G1 and Tara for organizing this, and G1 for helping me define how MuShop works, and making sure that I know which services they need to be deployed and which clusters. It has been phenomenal partnership. Thank you, Tara.
Oh yeah,
for
absolutely
organizing it.
Yeah. I mean, we enjoyed every minute of it too. Like, I mean, now, it's interesting that, like when you introduce MuShop as a complex application, that is entirely unintentional, right? Like it's supposed to be an example application, supposed to be as simple as possible, but we wanted to make it realistic, right? So many services all talking to each other, and like over a period of time, we've been adding stuff to it. So I guess it is complicated now, right? Like we should maybe take another stab at this.
It's just the real world, Jeevan. It's the real world, so
yeah,
it's a good one for.
No, I think look, we had to create a wallet and get all that stuff aligned, and then there are different microservices which does use different things, like book info, Istio based, right, which is pretty simple. But the one which you have is much more valuable. By the way, this solution works with Istio. and the Istio is an add-on on top of this. So none of this impedes any of the Istio solutions which you are working on.
Right. And I just wanted to make one point before we close down the call. At the risk of stating the obvious, right? Like, I mean, KubeSlice, one of the main reasons I like KubeSlice so much is the fact that it places absolutely no burden on the application, right? You can take an application as is, right? And make it work across clouds. And that's the beauty, right? Like you're not even an annotation has to change, right? It is absolutely seamless, which is really, really beautiful in my opinion.
Thank you very much, Ivan. Thank you.
All right. Thank you all so much. I will go ahead and conclude our webinar for today. Have a great day, and we hope to see you again next time.
Thanks, everyone.
Thanks, everyone.
Thank you.